All right. Hello, everybody, and welcome to the stream. I hope everybody is doing well tonight. We are going to pick up where we left off on the last stream, which was actually last week. Yeah, I missed last night's stream, but I'm doing much better today. So we are going to pick up where we left off there, dealing with our texture system. So, Saeed, how's it going over there on the YouTube side? Welcome. It's good to see you. Has been a bit. Hope you're doing well. All right. Before we jump into this, though, I do want to just take a quick second and thank the supporters of the channel, beginning with our elite partner, Javier Olazaran. That is the highest tier of subscription over on YouTube memberships and Patreon, as well as our partners, Gabolis Inc. and Matt Osgard. That is the next tier of subscription. Followed by all the names you see here on the screen. They are a combination of the other tiers of support.
Second Rob Dab.
Over on YouTube memberships and Patreon, as well as Twitch subscriptions. Speaking of which, thank you very much, Little Carlito, for the tier 1 sub. 3 months. I appreciate that. So, yeah, thank you all very much for the support. It means a great deal to me and helps me offset the cost of running the channel. Things like software licenses and assets, hosting fees, things like that. So, very much appreciated. And I would also be remiss without saying thank you to all of our viewers, whether you're joining us live on the YouTube side or the Twitch side, or if you're just viewing the VOD after the fact. Without you guys, the viewers, this project and thus this channel would not be anywhere. So it would not exist. So thank you all very much for being here and following along. All right. Little Carlito, how are you doing tonight? I hope you are doing well. Again, I really appreciate the support there. Thank you very much for that. Okie dokie. Now, where we left off last time is we started talking a little bit about filling out this sort of acquire texture acquisition with options. And we'd done a bunch of work on acquiring via these internal functions, the asynchronous and synchronous version. And then I got thinking later, it probably actually makes a lot of sense if we just go ahead and pipe everything through this options sync and async function likewise, right? And so essentially what that would require is just at this level, we fill out the options structure and then call this function. And then we have similar to what I was trying to do here with these internal functions, these guys will wind up getting replaced with the options variant, and then we've got all of our code in one place. I guess technically 2 places. We've got 2 different places that the code can proceed through, but it significantly narrows the amount of code that we've got, and we might even be able to find a way to pipe a lot of those things through the same sort of code path there. Diamond with the tier 1 sub, thank you so much. 18 months, holy crap, has it been that long already? I really appreciate the support, Diamond. Thank you very much. Very much appreciated. And you kicked off a hype train between you and Little Carlito, so thank you guys very much for that. It's greatly appreciated. Let's see, doing good, plugging away at 3JS editor. Ooh, that sounds like fun. I built one of those years ago. And that was actually, that's a pretty great library to use, actually. If you're going to use a library for 3D graphics, that one and Babylon are pretty good. I've used both, and yeah, they're both pretty good. All right, so in terms of where I got, last time we kind of had basically taken the logic out of these synchronous functions right here, this internal synchronous function. And we started putting it in here into the options sync function. And I've done a little bit of work offline, but I haven't had a whole heck of a lot of time to actually work on it. So I think I've actually got this, for the most part, complete, to the point where we can actually start piping the other functions through this one. And then we can work on the asynchronous version, which should essentially be almost identical to this, with the exception that we have to use a callback for the asynchronous asset load. But that's about it, right? Shouldn't be anything too crazy. The only thing that I think is going to be a little bit crazy is probably the instances where we're going to have to load multiple textures into a single texture. So that's for a layered texture or a cube map. But we'll take a look at that when we get there. Just as a review of what I've done. I believe we had all of this whole section here existed on the last stream. And so we've gone ahead and done some flag parsing here based on the various Boolean options in our options. So we have the depth, stencil, whether or not it's writable, whether or not it's should take multi-frame buffering into account, and then most of the work. Actually, I see something here I haven't actually gotten to, so we actually need to fill this out. Most of the work down here is already done in terms of assets. So this first if case here, let me actually just put a nice bright comment in there so we can come back to that. So this essentially is a couple of new options that I added to the options array, or the options structure rather, to allow us to immediately load pixel data if we already have that sort of thing loaded in memory. We can actually pass that as an option when we go to load the texture. And so we first check to see if that exists. If that doesn't exist, then we say, do we have layer image asset names, which is sort of the usage when we want to have multiple layers, right? So if we're using a layered texture or a array texture, this is what we'd want to use for each one of those layers, right? So we'd have the asset names for each one, for each individual layer, and then the package names for each one. If we're just using a single asset, then we would use image asset name or package name, right? So that's the difference there. And then we have pixel data and pixel array size. So if we have multiple images, then that means that we are likely loading into a 2D array. In fact, that's the only thing that's supported right now. So the way that this actually works is we do a type check on the texture to say, hey, are we trying to load a 2D array? If we are, go ahead and set the layer counts. Take a copy of the image asset names and package names. Now, the reason for this copy is because we don't know where these strings came from, and we don't want to have to worry about the life cycle of those things, right? So these string names right here and right here. And so we take a copy of those things, and then we can go ahead and free them after the fact. If the type is passed in as a cube array, currently we're not supporting that, right? I don't actually have something that uses that, but essentially a cube array would wind up falling under something very similar to how cube maps are loaded, but it would be a little bit more complicated in terms of supporting that. And I'm not 100% sure that we're actually going to need it. So for now, I've just put a fix me in there with a fatal error if we try to use it, right? And then otherwise, any other type of option in terms of, or any other type of texture in terms of texture types is not supported when using layer image asset names, right? So this is only for 2D array textures. And so we'll get a fatal message there as well. If we have a single asset, the first thing we do is we check, is it a cube map? If it is a cube map, we've got a comment in here that describes exactly what that's going to do. It essentially uses the image asset name as the sort of base name for the asset, and it constructs these names of images or image assets from that base string, right? So we've got front, back, up, down, right, and left. And you can see here, if the name was skybox, then it's going to append a underscore F, an underscore B, etc., right? And so all we do here is we just have a string that is just for all of the individual sides in this order, right? Front, back, up, down, right, left. And then we essentially create a string that uses the image asset name as the first portion, and then the character of the particular side that we're on, right? So it's a simple loop that goes through there and creates that. And then in terms of the package name, all it does is it says if we have a package name, use it. If we don't, then don't, right? And so that is how we load. That is how we load cube maps, right? For texture 2D, of course, the array size is only going to be 1. So we have one image asset name and one package name. And so we just take a copy of those strings directly. Similar to what we do here, except instead of doing a format, we do a copy for this guy. And then otherwise, if we have some other sort of texture type defined, then we do a check on that to see what it is, and then error out because these are not supported using just a single texture name, right? So that is that. And all that essentially does is build out a image asset names and package names array, right? And then we all have an array of pointers for assets. So let me just catch up on chat real quick, and then we'll continue stepping through this so that we can go ahead and have an understanding of what happens next. Let's see. Luke V. I'm not sure if I've pronounced your name correctly there, but hello. How are you doing? I hope you're doing well. I see you are subbed, so I appreciate that. Diamond, let's see. Doing a bit of exploration of assets and Path of Exile with a hex editor, and there's some interesting things. Apparently, they use something like 3-level paging where folders are named 0 to F, and nested folder is named 0 to F, and the path to an asset is stored as a 32-bit integer where the path is defined by 4-bit chunks, and then the remaining bits are defined where in that folder to find the binary asset. No strings. That's kind of interesting. And so if I were to, if I were to do that with the systems we have, I would wind up probably with a similar result, although not exactly done that way. So when we get ready to write our binary package, which we don't have yet, it's basically going to be a binary blob that all of our assets are loaded up into, or sort of rolled up into, right? That's going to have a lookup table in it that'll have a name and a byte offset of the individual assets, right? But instead of storing the string name, what it's actually going to store is it's going to store the hash. So it's going to store the K name of that, right? Which will just be an integer. And so it'll be a lightning fast lookup as far as that's concerned, because we won't really be using strings there. There will be the string itself will be stored in the package just so that we can retrieve the name if we need it, but we're not going to do lookups on that. So that's kind of what my plan is for binary packages when we get to that point. But that's not going to be until like way later down the road once we get close to shipping, honestly. Or at least once we get ready to start playtesting or something, or actually building release builds. Thank you for the follow, by the way, Angel Piecer. Appreciate that. Welcome. Okay. So once we have gotten to here, and we have our essential list of asset names, if we had asset names, right? We essentially go ahead and create the assets array, and then loop through each one of those names. And if we have a package name, then we use the request image from package sync. Otherwise, we just use request image sync. And then if we do not have an asset after that, right? So if this fails either way, Then we bleat about it, and we just kind of continue on, right? Now we probably ought to thinking about this now. This is actually going to cause a problem here. So this probably should be a fatal error, I'm thinking. Because otherwise we're not going to be able to get this stuff, right? I suppose... Oh, you know what? Copy pasta error. This should be sub I, not sub 0. Right. Okay. That would have been a nasty bug to figure out later. Okay. So I guess what we can do, maybe we do say this is an error, right? And then we say if assets sub 0 exists, then we take these properties, right? And then else, maybe we just sort of default to something else, right? So if not width, in other words, width wasn't defined in our properties or our options rather. We'll say if that's not defined, then we'll just say width equals 16, right? And we'll just sort of provide a reasonable default to avoid crashing, right? And then if not MIP levels equals 1, right? Oops. So provide reasonable defaults. I suppose we should probably also let's see, how should we do this? I guess we should say asset sub 0 not found using reasonable defaults. Right, maybe we'll move that up here, and we'll do it that way. Now, if there's a mismatch in image size, that's going to also cause an issue, right? But I believe we have logic down here to check for that, right? So what this does, this essentially loads the assets if we have assets, right? If we are not within this block, right, then we don't have any sort of assets that need to be loaded, right? So this handles the loading of any image assets that we need, whether it's one or several. And then we set our default auto release. Actually, that comment's wrong. Let's get rid of that. And then we go ahead and we acquire texture resources, right? So we go ahead and we use width and height. We go ahead and pass through the format information, texture type, all that good stuff. And so we acquire renderer resources, meaning the GPU resources that we're going to need to upload the texture. Check that. If it fails, we obviously go to the cleanup down here, right? So we've got that. And then if we have assets, what we're going to do here is we are going to do a sanity check on them to make sure that they are all the same size, because no matter what kind of image we're dealing with, if it is layered or if it's a cube map, all of those image assets must be the same size. And so generally speaking, we take the layer size to be the first asset, which again, this is actually going to be wrong. We probably ought to think about that a little bit more. Should probably think about that a little bit more, because asset 0 might be non-existent, right? That was kind of what we fixed up here. So layer size, let's see, how do we want to set this up? So I guess we could do, let's do layer size equals let's start off with 0, right? And we'll say if assets sub 0, then we'll do this. Otherwise, and actually this will be layer size equals, right? And then this will be, whoops, then this will be layer size equals width times height, and we're just going to assume 4, right? So that'll be, 4 bits per pixel, or 4 bytes per pixel. Okay, so we have that. So we calculate the entire size of the entire pixel array, and we allocate memory for the entire pixel array. So basically the way that loaded images work, or layered images work rather, is we load everything into a giant array that is segmented into even slots of memory, right? And so we say the first block of memory is the first layer, the second block of memory is the second layer, and so on. And so we feed that all into a contiguous array. And so that contiguous array is this all pixels array. So we loop through each one of our textures, grab a pointer to the asset, make sure we have the asset, and then we do a sanity check to say, let's make sure that the asset width is equal to the width and the asset height is equal to the height. This makes sure that all assets are equal to the initial width and height that we initially sort of allocated for, right? Because if we have a mismatch, we're not going to be able to use this, right? We're not going to be able to use that asset for that because all of those layers must be the same size. And that's not a Kohi requirement, that's a GPU requirement, right? That's just a way that array textures work. And cube maps are very much the same thing, right? So we do a sanity check on width, we do a sanity check on height, and then we do a sanity check on pixel array size versus layer size. And then, assuming that we're all good, we go ahead and we just copy the memory into that array using an offset. This offset starts at 0, so this is an offset into that block of memory. And so we just say all pixels, we offset into the all pixels array by whatever that offset amount is. So the first iteration will be 0. And then we copy in the pixels from the asset, right? And so that's what that does. And we've got a to-do here. Whoops. We've got a to-do here that basically says we want to make sure that the channel count is the same. So right now, this is just going to assume that all of the layers have the same texture format, right? This is why I have a to-do here. If the format's different, we're going to have to convert that pixel format first before we can actually copy the data over. For example, if we have the first layer of this is RGBA, and so the first asset rather was RGBA, right? Then we have 4 channels, right? If the second image is like a JPEG or was based on a JPEG, for example, it only has 3 channels, just RGB, right? It doesn't have alpha because it doesn't support it. And so if we were to import an image with just 3 channels, then we'd have to say, okay, well, we need to reformat that array of pixels to also include alpha data, even though that alpha data is just going to always be the same. The data's got to be aligned with all, between all the layers. So that's what this is about. We'll get to that at some point in the future if we need to. Right now, the engine always imports 4 channels no matter what you do anyways. So that's not an issue just yet, but if we ever change that, it could be. And then we have this this label here, the acquire with options sync asset continue. That's the go-to label that we have here in case of any errors. So what we do here is we release the image asset and then we increment the offset by the layer size, right? So we just move forward in that block of memory. Once we've completed that loop, we do a has transparency check on that, right? And we have this function here called pixel data has transparency. We'll come back to that in a second because that's a separate discussion. And then we go ahead here and we write the texture data, right? So this is the call to the actual render that uploads to the GPU. And then we validate that result afterwards. And if that finishes, then we skip down here to the cleanup, which would skip this success equals true. So if success is still false, then we would want to make sure that we release the texture resources and free up this slot, etc., right? Now, I am seeing here that we actually do have a couple of things that we need to go through and free as well. So we should probably go ahead and think about doing that. I believe, let's see, so these image asset names, are these used in this outer scope at all? I don't think they are. Let me go ahead and just double check that. They're not. Okay, so I'm going to take these and put them here. Right? Move this here and we'll space that out. Okay, and the reason I'm doing that is because if we have, let's see, if we go to this guy, oh, that's why I had them there. Okay, let me undo that actually. There was a reason that I hoisted those up. All right, so essentially what we need to do is we need to check if these things exist and free them, right? And same with assets, actually. I think assets we might have already done. We have not. Okay. So, we'll need to do that next. But before we jump into that, let me catch up on chat. Singy over on the YouTube side, how's it going? Good to see you. Casual Vim Enjoyer, good to see you as well. Hello. Thank you for the sub, by the way, over there on the YouTube side. Appreciate that. Let's see. First 8 bytes of each binary in the game assets looks like a unique ID that is associated with an entry in a manifest to check the match. I guess that makes sense if you're embedding it. Well, it depends on how you handle your manifest, right? So our assets don't have that. The first 4 bytes in our case is just a magic token that we search for. If it's a binary asset, which most of our assets are. And then from there, it loads the rest of the sort of binary header, the generic binary header that we have. So I don't think we don't really have a unique ID associated with an entry for our assets, but unless you count the name, which the name would be unique. So the name would be translated to a K-name, which is a unique U64 because it's a hashed string. So as long as the string it was created from is unique, it'll be unique. And there are checks done on that when we load up the asset manifest. So, Spiro, how's it going, buddy? Good to see you. 23rd or something. Yeah. Actually, you might not be right. You might not be wrong about that. I see 24 viewers at the moment, so you might have been 23. Okay. So, we do have some memory cleanup we need to do here. So I guess let's check. Let's see. We need to do this whether or not we have a success. So actually, we could just do this here. So we could go if assets, right? And this is just k asset image assets, right? Let's see. If we have, let's see. T should be okay. Let's do. We need to do a check to see if T exists first, right? The texture. Because if that doesn't exist, then we would not have gotten we would not have gotten the asset list anyway, right? So I guess we could just do, let's just do this. This will make more sense here in a second. So if we have an assets array, then we do k free type C array assets, and then the type is going to be k asset image. Oops. K asset image, and then the count is going to be, keep hitting the wrong key. The count is going to be t array size. Right, okay. So we have that, and then we're going to need to do the same thing with image asset names. Right, so this is going to be, the type is going to be constant character array, and then we do this one more time, but instead of assets, it's going to be package names, right? So we need to free these arrays, but we also need to go through and free the strings. So for u32, I equals 0, I is less than t array size plus I. Whoops, plus I, rather. And then if image asset names sub I, string free image asset names sub I. Oops. Right, and then we need the same deal down here. So this is just going to be package names, right? So that way we don't leak any of that memory. All right, let's see, was there any other things in here that I forgot? I don't believe so. I think that's it. Okay. So, we are always going to want to free this stuff no matter whether or not it's a success or a failure, right? If it exists. If we do fail, then we also want to free the texture, right? So we go ahead and do that. That's not going to have to change, and then we're done. Actually, I say we're done. There's actually one more step. We got to do this guy, which is actually going to be a simplified version of what we do down here for assets, right? So actually all we need to do, let's see. We actually probably could just do it here. Because all we really need to do is call render texture write data. Yeah, I guess we don't really need this extra case up here. So we really want this. We really want this down here. So we'll do, I guess we can do it right here. Thank you for the follow, Bit Casual. Appreciate that. Welcome. So we can do this guy here, and then we can turn this into an else if, right? Right, and so we can handle the pixels, the pixel data directly here, right? And so we can actually get rid of this. Let's see, where was the... There we go. Okay. So if we have assets to load, we do the thing. Load the assets here. Otherwise, if we do not have assets, then the only difference we're going to have is we are essentially going to do... oh, I forgot something here. We did this has transparency check, but we actually didn't use it for anything. So this should be t flags equals set. Where's it? Flag set. Flag set t flags. Texture flag has transparency. Has transparency. Why is this? Is it? Yeah, K texture flag. There we go. Okay. So we've got that. So we actually need to do this, and we need to do this right result. And that is actually going to be all that we have to do. So theoretically, in the interest of don't repeat yourself, I think we could probably... yeah, we can hoist this logic out of here. Right, because we have assets. Let's see, so all pixel size and all pixels. So let's actually take a copy of these for right now and put these here. Load pixel asset pixel data. Right. Now this all pixel size, we're going to default this to 0, and I'm going to default this to 0. Right. And then what I'm going to do here is do all pixels equals options pixel data, and then all pixel size equals options pixel array size, right? Then we can take all of this and put it here. Load, or let's say upload the pixel data to the GPU. The only problem is going to be if we just use options directly, let's see, where was that? That was here. If we use these directly, then we have no way to actually free this later on without knowing. Like, as here, we actually allocate a new array for this, whereas down here, or up here, we don't. So I suppose what I could do, let's just do this. Free pixels equals false, right? And then here, we'll do free pixels equals true. And then we'll come down here. And after we do the texture write data, then we'll do if free pixels we'll do k free, let's see, actually pixels is a U8, which actually is probably not correct either now that you think about it. Let's just do this for now. We'll do all pixels, all pixel size, mem tag array, right? So we'll free that pixel memory as well if we need to. And I think that's going to get us pretty much where we need to be. I don't think I'm missing anything. Okay. Oh, you know what? Actually, hold on. We can allocate this here, but we have a go-to here, so we could possibly wind up with a memory leak if we don't handle this correctly. We should probably do... Oh, wait, no. Yeah, it could skip this. Yeah, let's take this down here. So if free pixels, we'll say, actually, if all pixels and free pixels, right? We want to make sure that exists. Then no matter what, even if we error out, we clean up the memory. All right. Let's see. Do the problem-solving skills developed through LeetCode... Wait. Do the problem-solving skills developed through being good at LeetCode transfer well to game development? Some of it probably will. I mean... Yes, but like a lot of those things are sort of... It's not necessarily the actual problems themselves that will, but the skills in solving those problems will translate to game development well. Any kind of development well, right? So as long as you're not like memorizing solutions, but you're actually understanding how to solve their problem, then yes, those skills will transfer. But as I usually say, like if you want to get good at programming, just write code. Don't like sit there and write, LeetCode all day. Like that, sure, that can help, right? But like you're going to be way better off actually building something. Build something from the ground up. That will help you immensely. If you want to do that stuff to sharpen your skills in a certain area, that's fine. But like, don't spend too much time on that unless you know you're going to be applying for like a job that you know is going to ask LeetCode questions or something like that. But like, otherwise, I don't usually suggest spending too much time on that. It's not a bad thing to brush up on, but if you want to get good at game development programming, you need to do game development programming. Bottom line. Unfortunately, that's what they ask in interviews, even if you have years of experience. So yeah, that's the caveat, right? Is like, if you are interviewing for a job, right, that you know is probably going to have that kind of stuff, then yeah, it helps to brush up on that stuff. But in terms of actually getting good at the thing to practically solve issues and stuff like on the job, when you actually get the job, that stuff's only going to go so far. In the same way as solving equations translates to doing useful things with math, it's a bit nebulous to measure, but yes, yeah, exactly. So it's not like it's not gonna help, right? But like just doing that and not actually building something isn't good either. So you got to find a balance, right? Like I said, I would use it to hone your skills in a certain area that you know maybe you're weak at, but I wouldn't waste too much time at it. Personally. RNY served, first time chatter, welcome. Have no clue what I'm watching, but you seem to enjoy it. That's awesome. That's fair enough. I appreciate that. Yeah, so what we're doing here is we are reworking how assets are loaded into our texture system for our game engine. And so if that doesn't make sense to you, then the sort of you're watching high octane action packed content is what? Yeah, I know, right? So you know, if what I just said doesn't really make sense to you, then the best way I can describe it is, you know, textures in a game are sort of representations or can be used for representations of a surface of an object in the game world, right? And so we are sort of reworking the way that those things get loaded in to make it a little bit easier to use when you actually get ready to code against it, right? We've built this entire game engine from scratch, from the ground up. And we're in the process of actually building a game. We started building a game with it, but as with anything that is brand new like this, there are going to be like pain points, essentially like, hey, we thought this was going to work, but it's not actually all that easy to use. Let's rework this and make it easier to use. And so that's kind of what we're doing now, is just kind of going through some of those pain points to kind of tighten down some of our code, make it a little bit easier to use, so that working on the actual game is faster when we circle back to it. Hope that makes sense. Okay, so I believe we now have everything in this version of the function that we need. So we could probably split some of this stuff out. However, before we do that, what I want to do is let's go ahead and take everything that's in this acquire sync internal, and we're actually gonna wind up getting rid of this guy actually. So that is going to be this one here, which I believe we can just nuke. So the async version is something we're going to have to circle back to, but the synchronous version, at least, is much better off than where we were. Okay, so let's see. Texture acquire with options sync is what we want to use. This is going to be missing an argument, which is going to actually be k-texture load options. So we want k-texture load options. We'll just call this options, and then we're just going to do that. And then we'll do image asset name equals image asset name, right? And then let's see, what was the package name? Package name equals 0, right? And so we can actually just change out this with options. We'll need to fill out some other stuff there too. Thank you for the follow. I really appreciate that. Appreciate that support. I took a high school coding class, but it didn't really pay attention enough to actually learn all this. That's fair enough. So one thing that we've done on this channel is actually, and I know you're sort of on the Twitch side real quick, but I'm going to show you something on the YouTube side that may be useful. So we have, pull this up. So this is my YouTube channel. I'll go ahead and just drop this link in here, right? But what I have on here is actually an entire backlog of this entire series, right? So this is, it's actually kind of split into two series now because we're going back and forth between the game engine and the actual game. But we have this Vulkan game engine series written in C Kohi game engine. This playlist is the main one that you'll probably want to look at. So if you're looking to see how this project has developed since day one, this is going to be what you're going to want to look at. And this has 272 videos in it right now. So, obviously a game engine is a big deal, right? But we have all the way from episode 0, right? And so all the way down until where we're at now, which it takes a second to actually load up this, right? But we've backlogged all the content. So you can actually see the entire process of engine development that we've gone through thus far. And so that's there. And then this, the second sort of playlist that intertwines with that at the very end is the game from scratch, Shadows of Illumina, 3D action RPG that we're building using the game engine, right? So it's busted right now, so I can't run it, I can't show it, but we've done some of the work, some of the initial dev work here as well. So I hope that maybe that'll help. And if you're looking for more info about the engine itself, that is here at cohiengine.com. So I'll go ahead and drop that link there. And we have some info about the actual project itself. It's free and open source. It is available on GitHub. So it's very much a work in progress, early days engine, right? But we do have some notes here on requirements and setup and build and all that stuff, as well as the actual code access itself. So if you're interested in that, and or you're looking for a community of people to talk to about this, or just random game development stuff in general, we've got a Discord with about 1,000 people on it as well. Anyway, I digress. Let's see. If you were recruiting an entry-level dev for a game company, what skills would you be looking out for? So I'm going to stay extremely high level on this, right? Because that's going to be widely varied depending on what company you're applying for, what tech that they're actually using to build a game, right? Are they using Unreal? Are they using Unity? Are they using a proprietary engine?
Fun fact of the day: a group of owls is called a parliament.
That's so random, but thank you, 420 Cash Money Swag. It's a hilarious name, by the way. Appreciate that. Thank you for the 100 bits. So, are they using Unreal? Are they using Unity? Are they using a custom engine? Are they using, is the browser being targeted, right? Is it a web-based game? Or is it supposed to run on the desktop? Does it run on Windows? Does it run on Linux, Mac, right? There's all kinds of things like that. So putting all of that aside, the second part of that is, if you're applying for an entry-level position, are you wanting to build tools? Are you wanting to build the game engine? Or are you wanting to do game programming? Because those are also vastly different sets of skills, believe it or not. So writing game code is a lot different than writing engine code. And we're doing both here on this stream, but there's different skill sets. One of the biggest things I can say is you need to be good with linear algebra, or at least have a basic understanding of it, of how it works. Vector math, matrices, all that good stuff, trigonometry. You got to be good with that stuff. You'll need to know some sort of. You'll probably need to know, at least on a high level, a shading language, whether it's GLSL for OpenGL or HLSL for DirectX or MSL for Metal, whatever. You'll need to probably know at least one of those. The standard things, a lot of big studios are going to want you to know object-oriented programming very well. You probably, if you're going to be working in the engine, you're probably going to need to know things like Vulkan, OpenGL, DirectX, Metal, things like that. If you're just working on gameplay code, then you're probably going to have to have some experience writing game scripts, which again, like I said, is vastly different. If you're using Unity, you'll want to be experienced with C# versus if you're using Unreal, you'll need to know C++. It's kind of a long list of varied skills. So, entry level, I would look for at least some of that stuff. Not necessarily check off every box, but the other thing you could do also is look around at some postings, some job postings out there for different companies, right? Even if you don't meet the criteria, go out there, look at what job postings are out there for different companies, large and small, right? Look at what they have listed and try to kind of feel out the themes of what's going to be required for each of those positions, right? Whether it's engine dev or whether it's game dev, or even if it's like an MMO, maybe the back end dev, managing, API endpoints and databases and stuff like that. Um, you have to learn object-oriented programming. Unfortunately, you probably are going to have to. Uh, if you are a going into a large company, you're going to have to know that stuff because all of those large companies use that. I try not to use that here, right? Um, and as you said, Casey's Handmade Heroes series also looks down upon it, right? I am getting away from object oriented programming for a lot of things. We do things here that kind of touch on some aspects of that, but we try to avoid it at all costs here as well. But yeah, it is something. I'll say this: even if you're not going to use object oriented programming, you should still learn it, and here's why. Learn how it works, but also learn how it works to the extent so that you know why you don't want to use it, right? Don't just sort of blindly accept I shouldn't use this thing because somebody on the internet said it's crap. Understand it, learn it, understand it, and then try to pick apart why certain folks are saying object oriented programming is not always the best thing, right? It has its uses, right? Um, Game development, at least at the engine level, tends to not be as much that case, right? Although larger engines like Unreal are heavy object oriented programming. So, yeah, it sounds like a little bit backwards, learn something that you're not going to use, but you probably are going to use it realistically. But you should also learn you know, why people are saying it's not good, and try to form your code around that. All right, let me catch up over here on the other side. Sweet, I'll definitely check that out. Okay, good, cool. Let's see. You don't learn this in high school or even college. This is just from trying. Yeah, so you learn this stuff by doing, right? By doing lots of reading. And I do mean lots of reading. Both language specifications, white papers, tutorials, although I would somewhat limit those once you get past basic knowledge. And of course, reading examples of source code. Let's see. Going into the game industry right now, I think your most important skill is unfettered optimism. Yeah, you're not wrong there. Unfortunate, yeah. You're welcome. My work here is done. I'm off to share fun facts somewhere else. Catch you on the flip side. Thank you again, 420. Appreciate that. Do game dev companies hire like fresh noobs? So when you say fresh noobs, define that a little bit for me. How fresh? How much, what experience do you have? What are your skills? What do you know? Because, are they going to hire somebody that can't program at all? No. Competition's fierce. It's no joke, right? Let's see. Learn how professors think you should do object oriented, then learn from people like Rich Hickey so you get deprogrammed from making sprawling, useless abstractions. Absolutely. Learn OOP and C# for games. You can always fall back into a back-end job. That's good advice too. Yep. If you learn C# and OOP, using C#, that'll get you decently far, especially if you wind up landing in a company that uses Unity. But what I also say is, even if you wind up getting good with C#, I always suggest people learn C. And if you're going to learn C++, I always say learn C first and then learn C++. Because then you'll understand some of the things that C++ is doing for you, for better or for worse, much better than if you try to do it the opposite way. Let's see, college kids that didn't do much personal improvement. This is not me. Oh, yeah, I gotcha. Yeah, so, I mean, that's the other thing is you have to have a strong motivation to constantly be learning. because doing this stuff requires a lot of different knowledge in a lot of different places. I myself am still learning new things all the time, and I've been programming since I was 7, and I'm still learning new stuff every single day, just about. If I were to follow the series and make my own engine, would that be even enough to be considered as an entry dev? Um, it might be. It might be. I would say though, the series that I have here assumes some knowledge though. It assumes that you know a little bit about graphics programming stuff, a little bit, not a lot. It assumes that you know some of the basics. It assumes that you know some of the linear algebra and trig. It assumes that you know C or C++. I do have a little bit. I started making an Intro to C course on my channel that's free, but it's far from finished. So I would say supplement it with other things. If you're following Casey along, that's definitely a good place to start as well. He's got a pretty good Intro to C as well. I think he calls it Intro to C, but he writes it in C++. Like he writes C style C++. If I remember correctly. But yeah, one of the things you're going to want to have to get considered, you're going to want to have this knowledge, right? But you should probably also, like, if you're, and again, this depends on whether you want to go game engine route or game dev route. If you're wanting to go game engine route, you should probably write your own renderer, and then have that on GitHub somewhere, right? Write a basic renderer that can do some stuff. Whether it's an OpenGL or Vulkan or whatever, doesn't really matter which graphics backend you pick, but have a sample of your work out there. And if you've never written a renderer before, prepare to write a few, because the first one you write is going to be rubbish, along with the second or third one. But every single time you do it, you're going to learn a lot. And just by repeating that and throwing out your old code and going back in and diving in and making another one, it's going to reinforce all of those concepts just by the repetition of it. So you definitely want to have some sort of an example of your work. Do whatever gets you hired. Yeah. So you definitely want to have some sort of example that you can point to be like, hey, I wrote this thing. I've got this shiny renderer on GitHub, and put some screenshots up there so that they can actually see what it looks like if they don't want to pull it down and build it. But that kind of thing can go a long way. I know when I was doing interviews when I was working at a game company several years ago, that was one thing I always look for too. Like if somebody actually had samples of their work, that was something that weighed pretty heavily in the interview process. So, but again, it varies widely depending on what you're going for. I hope that helps. I know it's kind of generic, but unfortunately it's a really loaded question. Hazel series by Cherno and Handmade Hero are good series if you prefer video material for learning. Yeah, Hazel is very OOP heavy, and Hazel also makes use of a lot of third-party libraries, which can be fine. The only problem I have with that is you gloss over a lot of really important concepts by doing that, versus writing it yourself and going through that pain of writing it yourself. But yeah, I mean, I agree otherwise. It shows you a way to put together game engine just like this. It shows you a way to do it. Any good recommendation on learning C? So I actually learned. I picked it up initially from this book, which this is actually kind of aged now, but it's Sam's Teach Yourself C in 24 Hours. That's not like one day, that's like 24 cumulative hours, right? This is a bit of an old book at this point, but C hasn't changed all that much. Generally speaking, you'll probably want to stick to C99 when you're first starting. But usually the advice I give to people for learning C is once you get past the basics of, syntax and writing functions and loops and branching and recursion and all that kind of stuff, once you get past all the basics, I usually suggest to people to implement a string library that you would normally find in a higher level language like C Sharp. Implement that from scratch in C, complete with memory management and everything. And by the time you get done with that, you're going to have a pretty decent command of the language. Because manipulating strings gets complicated quick. And the more robust you make your library, obviously, the more complicated things you're gonna trip over, right? So I would say that's usually a good project to get a command of C. Trying to change my field to embedded systems engineer from backend. Ooh, that's a big jump. Quite a different jump, I should say. That's kind of awesome, though. I mean, that sounds like it would be interesting. Like, I would probably do that if I wasn't so, decently happy where I am. For basics, Google Beej's Guide to C. Yeah, that's a good one. It's a bit dated at this point, but that's a really good one as well. Yep. But yeah, like I said, once you get past the basics, write a string library. Let's see. Tired of Java? It's been 4 years and doing CRUD. Yeah, I feel you on that. I feel you. All right. I think I caught up to. Yeah, I think I caught up on everything. All right. Where were we? We were filling out this options, right? So let me just. We don't need pixel data or pixel array size. We don't need layer images. We have the image name and package name. Our default, we're going to use name for name. We're going to use image asset name as well for that. Let's see. We don't want to set a width, a height, or a depth because we are loading from an image asset, so that's always going to be determined for us. Format and type. So type will need to fill out. Auto release will need to fill out. So type equals 2D by default, right? Auto release is going to default to true. Let's see. We don't want writable, we don't want depth, stencil, or multi-frame buffering by default. So I think that's actually all we need to fill out by default, right? So whenever we default or acquire a texture just using the image asset name only, we essentially just fill out this guy and pass it to here, and then return that, right? So that's a lot lighter even than what we had. And then the package version of this, which is down here, is going to be almost identical. The only difference being is package name is going to be package name. Right? We'll use that instead of null. And so now we actually have to do the asynchronous version of this function. Always wanted to be an embedded engineer. Circumstances did not allow me. Finally, I'm starting to switch. Yeah, that kind of programming has always interested me. The problem is I could not find jobs doing that stuff. It was one of the barriers to entry for me. Maybe it's a skill issue. I don't know. Could be. All right. So now we need to think about the asynchronous version of this, right? So we have with option sync. Do we not have? Oh, it's this one. Okay. I wonder if we should call this async and sync, or just leave it as options is just the with options is just the async version. Yeah, I think that's fine. All right. So the thing we have to think about here is this listener and callback situation. So the way that this works is we acquire the texture handle, and then we request all of the assets. Once all the assets are loaded, then we issue this callback, the user callback as we're going to call it, with the listener passed along as context. So most of this logic is going to be repeated. In fact, I think what I'm going to do initially is I think I'm going to go ahead and I'm actually going to copy this logic, and then we're going to deduplicate it, right? Kind of like what we did before with the previous version of this function, but I think we're going to rewrite it and just nuke the other one. So let's copy that, pasta that right there. And then obviously we'll have to set up some sort of internal callback for our synchronous stuff. So all of this can remain the same. All of this can remain the same. There is one minor requirement here. So when we get the texture, if it exists, we can return t, but before we actually do that, so we increment the reference count and then say if callback, if a callback's provided, right? So this is the case where the texture's already been loaded. It's in our texture cache. And so we don't need to reload this. We can just return a pointer to it, right? But since this is asynchronous, we have to return a pointer to it, and we also have to make this callback with the listener, right? So we have to do callback listener, I think is. Thank you for the follow. Thanks for the questions. They answer the questions and commentary. Follow for sure. I appreciate that. Have a good one. Thank you for the follow. I'm not going to pronounce your name because I don't want to curse, but yeah, that's very funny. Mighty Dev, thank you for the follow. Appreciate that. You work at Apple as a contractor? That's pretty cool. Once you have enough knowledge and something to show, you'll talk internally and see how it goes. That's awesome. Well, good luck on that. That's pretty awesome. Yeah, that's if you already have a foot in the door, that's like half the battle, right? All right. So we need to pass the texture as well. There we go. Okay. So immediately make the user callback and boot. So that's that. If we do not have the texture in the texture cache, then we have to go ahead and get a new slot. Fill all this stuff out. This should all be the same. This should all be the same. This here, where we're actually getting the, we're building up the image names and package names array, that's all going to be the same. Where it's going to vary is this bit right here, right? So in the event of we have image assets, that is where we're going to actually have to split the logic. So if we have if we have assets, what we're going to have to do is request those asynchronously, provide callbacks to be made once those assets are loaded. And we might have multiples of them, right? So if we have assets, that's the way that we're going to work, and then we'll make the user callback within that sort of listener callback that we're going to have to set up. If we don't have that, right? If we don't have that, then we don't actually have to branch off at all, right? So if we have image asset names in this case, and we've done all of this stuff, then we're actually just going to return t right here, right? And so we're going to say note all of the, oh, wait a minute. I can't quite do that there yet. I have to do this step first. Oh, wait, no, I can't, because I don't have the width and height potentially. So I was correct. Okay, so note return pointer to texture here, because all of the resource acquisition and pixel data upload must be done after all assets are loaded. Right? So we'll do return t here. Okay? Otherwise, if we're just loading pixel data, we can't actually do that, right? So, we may have some cleanup situations to think about here, but I'm not going to worry about that for now. We should probably also take this flag. That should be moved up here. Thank you guys for the follows, by the way. Appreciate that. Okay. So if we're just loading pixel data, then we're good, right? We'll have that because of what happens here. So technically speaking, we're not going to need this stuff. Okay. This is going to get a little bit weird, but we'll figure it out. All right, so we had a context in here somewhere, listener context, I thought. User listener. Yeah, it's this. So we're going to reuse this guy. So texture, asset, load, listener, context. Okay, so here's the texture. We kept the name and the image asset name, I assume, for reporting purposes. So this is the user callback, the user listener. Here's the pointer to the texture. We need U32. Well, actually, yeah, we can get the count of assets required from the layer count, I guess. So let's do K asset image assets, right? And then note size of array is texture layer count, right? So we need to know these assets. Image asset name. Does this store the name anymore? I don't remember. I don't think it does. No. Okay. Oops. So we're going to have to store an array of names and an array of image asset names, which is fine. Names, and then an array of these, which is image asset names. Don't worry about these errors here. We're going to fix this afterwards, right? We're going to get this stuff sorted first, and then we're going to go back and fix the rest of the system. Thank you for the follow. Appreciate that. Welcome. So here is the image loaded. We can reuse this guy. But his logic is going to have to be based on the bottom portion of Can I actually use this? No, not really. I'm just going to nuke this. Let's just get rid of that one. And let's get rid of it from up here as well. Let's see, this one. Okay. So what we want is image loaded. This is where we're going to fill that out. Okay, so let's take a look at... oh, thank you guys for the follows. I appreciate that. Welcome. Stretch redeem. All right, I'll take that. I could use it anyways, if I'm honest. Thank you for that. Ooh, I really did need that. Okay. I don't know if you guys can hear it, but my joints are all like Rice Krispies, you know, snap, crackle, pop. It's hell getting old, let me tell you. All right. So, let's go back to with options. And we want towards the bottom of this, we actually need a copy of this stuff. I don't want to cut it out of here because there's going to be some of this that has to stay here. And we're going to, like I said, we're going to deduplicate this stuff later. I just kind of want to get it working for now. So let's copy that. And then an image loaded. Let's take from here and let's do that. And I fully realize that, you know, we've got a lot of errors here that we're going to have to step through, but that's fine. Okay, so texture K asset image loaded. All right, so what I'm going to do is I'm going to step back and fix the other function first, and then we'll come back and fill this one out. So with options, when we come in here, if we have image assets, right, we are not going to use the sync version of this anymore, right? So we're going to get rid of sync. This requires 2 more arguments, right? So we're going to actually have to set up a listener, right? Let's see, what was it? Texture asset load listener context. So we'll just say listener. And we need to actually control the lifetime of this, right? So we can't allocate this on the stack. It's got to be dynamic memory, right? Texture asset load listener context, and then mem tag texture, I think is what we put that under. Mudbound Dragon raiding with a party of 26. Thank you so much for the raid. How's it going? How was your stream? Shout out to Mudbound Dragon. If you guys are not following him, you definitely should be. Welcome, Raiders. Did some Pico 8. How's it going here? It's going pretty well. Yeah, I've seen some of your Pico 8 stuff. It's pretty awesome. I lurk your stream from time to time whenever I have a little bit of free time, and you're doing some pretty awesome stuff over there. Pico 8 is one of those things I want to pick up at some point. But yeah, so what we're doing here is we are actually we're building, or I guess we've kind of built a game engine from scratch, but we are enhancing it at this point. So it's called the Kohi game engine. It's a game engine that we built as a sort of educational exercise using C and Vulkan as our initial rendering backend. So it started as a tutorial series, and we changed formats a few times, eventually landing on the live stream format that you see here. So we stream to Twitch and YouTube simultaneously. The engine itself is free and open source, and so it's available here on GitHub. In fact, I'm going to post a link in chat. That link is to this website, which is sort of the central hub for it. But the engine itself is free and open source. It is Apache 2.0 licensed, which means that you can use it for whatever you want, whether that is personal or commercial. It does not matter. All that I ask is that you say that you use it if you use it. And so there will never be any sort of royalties or license fees or anything of that kind. This is designed to be an educational resource. And so we have a basic PBR pipeline that we've set up. And these are a couple of, albeit dated, screenshots. We've actually added some more to here. But we've got basic object rendering. We actually added water recently. We've got a PBR pipeline set up. We've got the ability to render different types of text, including UTF-8. We've got a basic UI system, and all this stuff was built from scratch. And so this whole series shows a way to build a game engine. It's not necessarily the only way, and it's not even always the right way. Sometimes we sort of take exploratory diversions and try things that don't work, right, to figure out why they don't work, right? And so sometimes we get it right, sometimes we don't get it right, but we do a deep dive and exploration into those things either way. And so this has just got a little bit more information about that. We do have a Discord server with about 1,000 people on it. I haven't checked that count in a while, but I know it's at least 1,000. Some links on here to like YouTube, Twitch. The GitHub link is down here as well. And then there's the stream down here at the bottom. And then a Patreon link, because I don't have any like sponsors or anything like that. The only sponsors I have are the viewers. But like I said, that's not required. I don't paywall anything. That's purely optional. So what we are doing right now is we are actually doing a little bit of an overhaul on our texture system to simplify the way that assets are loaded. And we have two different processes of loading assets. One of those is a synchronous process, and the other is an asynchronous process. And so the idea is that our asset system is going to be jobified and already has an API in place to do that, which means that we can multi-thread asset loading. So obviously that will speed things up and allow us to load multiple things at once. And so we are in the middle of writing actually the asynchronous version of texture loading after an asynchronous image asset load. So that's what we're in the middle of now. Just kind of reworking that to make it a lot easier to use on the surface, because I'm trying to go for API simplicity, right? So part of the thing that's happened with any tutorial series or any project of decent size is you kind of incur technical debt, right? The way that we did some things here is because of the tutorial format, and so we have a little bit of tech debt that's been built up because of that, and we're sort of knocking that out a little at a time. So I hope that makes sense. Posture check, okay. I think I actually did that automatically, but thank you for the redeem. All right, so the whole goal with this, like I said, is it's supposed to be educational. So the idea is that I'm trying to encourage people to want to do deep dives into this technology so that we get a little bit more competition in this space. Because we've really got sort of the big three game engines that are out there, and there are some independent ones, right? But like I want to inspire more people to actually go out there and get their hands dirty and actually build engines, because competition is what drives ingenuity. And I'm hoping that this will eventually inspire somebody to make something really awesome. And so the idea here is that we're building a game engine, and then we're also building a game using that game engine, and we're going to release it eventually on Steam and maybe other platforms in the future. Steel Flex Jones. That sounds sounds interesting. Where did you learn to make game engines? By making game engines and studying game engines. And I also did it professionally for almost 5 years. But yeah, it's technically my first brush with game engine dev came back in like 2001, I want to say, with the Torque game engine. Um, and I eventually wound up writing the material editor for that engine in combination with a couple of other guys. And then I wound up doing it professionally for a few years as well, writing proprietary game engines. And then on my own, because I'm a massive nerd, I've just written game engines for various other projects, contract work and other stuff like that. And on my own, because I love it. Josh C. Cooper, thank you for the Prime. I really appreciate that support. Thank you very much. Yeah, I mean, it just wound up being one of those things that I just kind of jumped into and really found out that I love. Yeah, I do it for fun, which sounds crazy, I guess, but when it's something you love, it's not really work. Zero X Machine, first time chatter. Hello, how's it going? How close are game engines to something that handles simulations under the hood? Depends on the simulation, right? Because you could argue a physics engine like PhysX or Havoc or something like that, right, is a simulation, but those technically do not have renderers, right? That's just a form of simulation. I've seen other types of simulators for like running tests really fast for like slot machines and stuff like that. That's another type of simulation, right? So like simulations are that's kind of an open-ended thing. It can be visual or not. So you can have a visual simulator. You can have something like The Sims also, but all that stuff is, something like The Sims is built on top of a game engine. So a game engine is basically, I suppose the definition of it is it's really just a suite of tools that allows you to build a game engine. So it's the editor, it's the sort of runtime code base that you build on top of that handles the lower level things like rendering, sound, input, physics, networking, things like that for you, file rating, things like that. So game engine generally handles all those things for you, and then you build your game on top of that. So it's both sort of a library of code, but then it's also generally a suite of tools like an editor and other things that kind of surround that at the same time. And it's kind of grown, with the advent of commercial game engines like Unreal and Unity, that's growing all the time as to what a game engine actually is. Let's see. Hello, thank you for the YouTube series. Extremely helpful to me. What is your opinion on new languages such as Rust, Zig, Odin? Are they worth any attention relevant to the game engine sphere? So, I will say, I am not qualified to speak on those because I've not used them. However, Zig and Odin look pretty neat. My concern about those is they are still relatively young languages. And I would be concerned about using those in a production environment if I ran into an actual language bug. And I say the same thing about Jai too, right? Sure, they're very far along, but they're not as tried and true as something like C, right? Or C++. And so I would probably try them out on like a toy project, but I don't know that I would use them in production yet. Rust, I guess, is a little bit different, but again, I'm not really qualified to speak on that because I've not used it in depth. It's something I'm willing to try at some point, but at this point, this engine is written in C and it's pushing 80,000 lines of code at this point, so I'm not really wanting to move tech stacks, How do you resolve image layout transition? Do you collect all textures in one point of the game loop, transition them all in one queue submit before rendering, or do you do it differently? So all of my operations like that, whether it's transitioning an image layout or whether it's uploading texture data or whether it's buffer copies or blitz or any of that stuff, I have a temporary solution that I'll say, where the first part of a frame, I do a certain amount of that work. And sometimes I can defer that to another frame if there's too much of that work to be done. But basically what I do is I preload that before rendering the next frame, and then I just submit it all at once to the same queue. And I have everything loaded on a single command buffer, one per frame in flight, essentially. And so I basically just fill up the very beginning of that with those types of operations, and then I handle all the rendering stuff after that. And then generally any of that type of thing that I'm doing, is done by the time I've moved on. I do use secondary command buffers as well, with some barriers here and there to kind of break some of that stuff up. But yeah, I hope that answers it. So eventually what I'm going to do is I'm going to have the Vulkan render itself is going to be multi-threaded, and I'm going to have a second queue and a second on a different thread and a second command buffer that I'm going to use purely for those types of things. And that way I could just kind of ad hoc just toss them out there, right? And that's kind of the eventual plan for that. But I hope that makes sense. So I basically just preload the front of the frame. Hannibal, hello, how's it going? First time chatter, welcome. Thank you for the follow also. Let's see. How old were you when you started programming? 7. I was 7 years old. And I know I'm going to be dating myself by saying this, but I started developing on, was it a 386? I think it was a 386 with 640K of RAM, MS-DOS 5, and QBasic. QBasic was the very first programming language I learned. And that's, if you've ever looked into it, it's like an archaic programming language that came with DOS way back when, but it had a manual on how to use it and everything. So you didn't have to connect to the internet to learn how to use it. It had a manual. And that was, I started messing around with that when I was 7, which is a long time ago, unfortunately. Imagine there's a bit of overlap, but I was thinking more like how flight simulators or astronomy simulators for more complex calculations. I've noticed engines like Unreal have a simulations template, but I'm not sure how that differs from the game part. I can't speak to how their templates work, to be completely honest. So generally, what a game engine does is it tries to handle a bunch of things within this time span of a single frame. Which if you're talking about your average 60 frames per second, that tends to be about 16.6 repeated milliseconds, right? And so once per frame, you've got to handle input, you've got to process your physics, you've got to handle any sort of world updates with things moving around, things updating state, that kind of thing. You've got to queue up and draw everything that you see on the screen. And that and a whole bunch of other stuff in terms of sound and other systems, networking, all those kind of updates. You've got to do all that within the context of that 16.6 milliseconds, right? And so it is a tight loop that just kind of sits there and runs like a simulation would. And generally, when you're talking about a simulation, as far as a game goes, a simulation is another step in that process, right? So you have the physics step, you have the sound step, you have the input processing step, and then you'd have like the simulation step. Would it just be another system or set of systems that runs within that? I hope that makes sense. Note both Zig and Odin are used in production, Bun and Embergen. Yes, I know they are, but I don't know. And again, like I said, I haven't used them, so I'm not really qualified to talk on it yet. But I still probably would not want to risk using them for a project of this size. Because by the time we're done with this in the game, it's going to be well over 500,000 lines of code. If not 1,000,000 lines of code. I think Rust gets in your way too much to justify its use for projects where The added guarantee isn't necessary. I tend to agree with that. I messed around with Rust for about a week and I got really annoyed by how much it just slaps you in the face all the time. You have to think about it completely different, and I just wasn't willing to make that jump at that point. So at some point, I will try it. I'll give it a fair shot, but Rust also sucks for concurrency, and any type of threading is miserable in Rust. Really? That's interesting. Why would that be? Haven't used Rust for concurrency much, but I know for a fact it's also very easy just to get concurrency totally wrong in other languages. So I don't know that that's unique to Rust. I would agree with that too. Concurrency is easy to screw up in any language. Very, very easy to screw up, for sure. 7 years old, hot damn. Yeah, I'm a giant nerd, like I said. Sorry, I made a typo. I started coding at 10 years old. Oh, Josh. Okay, that's cool. Let's see. MS-DOS 1.25, 2.0, and 4.0 source code is on GitHub. I remember reading about that, but I never bothered looking at it, to be honest. What percentage code do you reuse when you make game engines? So you mean from game engine to game engine? The only thing that I've ever really reused is maybe parts and pieces of my math library. Other than that, not really much. Just because, well, several reasons. The requirements might be different between game engines. Also, a lot of the game engines I've written in the past were under NDA and were strict closed source, and you can't do that, right? So there's definitely no reuse there between engines for sure. But yeah, I mean, I think maybe some math functions at most, but like most of it, straight from scratch every time. To be fair, pretty sure Ginger Bill himself works on Embergen. So maybe that was a bad example. Yeah, and it might have been, right? Because he's going to know how to work around the issues in his own language, right? Not discounting it, right? I'm just saying it wouldn't be something that I wouldn't want to get 100,000 lines into it and then be blocked by a language issue. You know what I mean? Let's see. Probably uses a lot of concurrency to keep track of real-time changes for different aspects. Seems like so much work just for a game engine, though. It's cool that you have a project like that. I used to watch Chrono work on his Hazel engine. I assume you mean Cherno. But it didn't really help me back then. Yeah, so I watched his videos too, all the way back when he was doing the Sparky engine, if you guys remember that. Yeah, I watched his stuff a lot back in the day. Not so much these days, just because I'm too busy with my own stuff. But yeah, it definitely is a lot of work, but it's really rewarding when stuff actually starts to work. Super rewarding. Object ownership guarantees are hard when you have threads. Yes. And that's true in any language. I would say that's probably also not unique to Rust. Let's see. Different language standards too. Copying older code means you avoid opportunities to refactor using better or more modern methods. That too. Yep. Generally speaking, I always try to write things brand new. If I'm working on a new project, I just try to write it from brand new. Sometimes I might go, oh, how did I do that in this other project? And if I can use that code, I'll do it. But it's generally not like a copy pasta. It's like I go over there and I'm like, oh yeah, that's what I did. And then I rewrite it from scratch anyway. Remember Sparky? Those tutorials sucked. Yeah, that was a long time ago. He was pretty new at it then. You started with Brain F. Yeah. I try not to curse too much on this stream. I do every once in a while, but yeah, that's a super hilarious language though. He goes super high level stuff. Wait, like he'd go super high level on stuff in Sparky and never in depth. And then he'd write some stuff off stream and it was like the entire engine. Yeah, I mean, I've written some things off stream, but like what I try to do is like kind of like what we started on this stream tonight, right? If I do some offline work, the next time we come in, I will walk through that and be like, this is what it was. Because With a project of this size, with how much stuff we have to do, if I were to only code while I'm streaming, which I can only afford to do a few hours a week, we'd never get anywhere. But yeah. So, holy stream delay. Is the stream like slow or something, or is it just not? It looks like my bitrate is good. Most tutorials sucks. That's just how it be. Yes, I agree. Quality is rare and information is prolific. I would agree with that. Yeah. Tutorials are never really meant to give you a total in-depth of knowledge, right? Like if you want to learn Vulkan in depth, don't follow a tutorial, right? Tutorial is good for introduction, high level stuff, very easy concepts, very high level concepts, right? But if you really want to learn something like Vulkan, for example, read the dang spec repeatedly. You have to move away from tutorials at some point. And I say that having made tutorials, but yeah, that's why we moved on from tutorial format to this format. And also this is better because I get to interact with you guys. First language is HTML and then C++. That's quite the jump. Interesting combination. Yeah. I want to make courses that go really in depth and focus on best practices for language. But, wait, for languages I use, but it takes a certain kind of person to teach via recording streaming, and it is a lot of work. I can attest to that. That's another reason, actually, we switched to live stream format here, because I started off this series in tutorial format, and that is a crap ton of forward preparation, right? And then you've got to do the recording, and then you have to do the editing, which takes even longer. And then finally you can post it, right? Whereas this is just kind of on the fly, brain dump, you know, it's much quicker. I can actually just write the code here, explain what I'm doing as I'm going through it. And I find, and I have been told that it's much better to do it this way. Because a lot of folks pick up on it better when I'm explaining something this way than a structured tutorial, except at the very beginning. That kind of work also goes unrewarded. Yeah, people will out-earn you by making shallower content that takes less effort because they can produce more of it faster. It's a problem with incentive structures. Ain't that the truth? So yeah, if I was concerned about the money for this, right? If that was my primary concern, I wouldn't be streaming this. I would have made like a whole course website and like planned out the whole thing and done it that way, right? But I don't feel like that's as valuable. And if there's an issue with it, that's really hard to fix, especially if it's an issue that occurs early on and then it's something that, you know, causes a big problem later on. Like it's very hard to make that work in course format. But also, yeah, I tend to find that a lot of courses don't go in depth. And actually, having written some of those courses in the past, a lot of the publishers don't want you to go in depth. They want you to keep it short and succinct. They want to be like, for example, they'll be like, write up a course on how to make, I don't know, a mobile 3D game, right? But keep all your videos to 5 minutes or less. How much are you really going to be able to cover in 5 minutes, right? Do you enjoy looking at your jobs code as much as you do this code? Nope. If not, why not? Because corporate code is never as nice to look at as something that you're writing on your own. For one thing, it's heavy oop, right? Which I'm never a fan of. But also when you have a lot of people with their hands in the pot, that tends to come with its own set of issues, right? So, I mean, it is what it is, right? The reality of it is you got to go and you got to do the thing to make your living, right? And there's nothing wrong with that. Obviously, I don't enjoy looking at that code like I do this code, but it's work. It's not supposed to be necessarily all fun and games, candy and cake, Let's see. I agree, but I'm heavily reliant on the first stages of learning someone in some format to show me what to do. And that is fine, Device Serial. First time chatter, by the way, welcome. So that is fine, right? That's perfectly fine. I tend to be the same way when I'm picking up a new concept, right? What you don't want to do is you don't want to get stuck in tutorial hell. You don't want to get stuck so that the only way that you can work is tutorials. Like, use the tutorial as your, to form the foundation of your knowledge, and then learn how to build and search how to do things to build on top of that. And as long as you do that, you'll be fine. I feel like most tutorials should be free. So many expensive courses that don't even go into the important details. Yeah, I tend to agree, right? Like, I don't know. Like, I could be shilling courses and probably make a killing, right? But, like, I don't feel that that's valuable. And all right, I'm going to go on a tangent for a second about this. So, I went to college for game art and design, right? I actually have an art background, not programming, when it goes back that far, right? I taught myself how to program, and I've been programming a long time, but I didn't actually go to college for that, right? I went to college for game art and design, and I spent a whole bunch of money, and at the end of it, it's all stuff I probably could have taught myself. Acquired a whole bunch of student debt for things that I realistically could have done on my own. Probably not as quickly, right? But certainly for a heck of a lot less money. And I feel like a lot of these courses online are kind of the same way. Now, I can't speak for all of them, right? I'm sure there's lots of really good ones out there. But there's also lots of free stuff that's out there. The thing is you have to be able to identify what of those are good and what aren't. And sometimes you can do that on your own. Sometimes you can't. Sometimes you have to rely on other people's opinions or reviews or something like that. But if I could do it over again, I probably would not spend all that money on essentially a large set of courses that is college to learn how to do this stuff, because it didn't teach me, like, this game engine stuff. I didn't learn any of that there. That's all on my own. I learned mostly stuff about, like modeling, rigging, animation, that kind of stuff, game design stuff, right? But, like, I could have learned that stuff for free online. Granted, this was at a time where there weren't that many online resources as there are now. So this was, 2004 to 2009. So there wasn't as much of that stuff online, but it was still there. But yeah, I tend to kind of feel the same way about that. In general, about most college and most courses, right? At least in this field. So that's one of the reasons I've made all this stuff free, is because I don't have any sponsors. I don't get an income. I don't paywall any of this stuff. It's educational, and I think that stuff should be free. I think that that's what makes it valuable. I think it's a valuable thing to transfer this kind of knowledge to other people, instead of, sort of gatekeeping it and charging for it or paywalling it or any of that stuff. I feel like it's a lot better to spread that knowledge and have other people get good at it too. Hopefully even better than me, and go out there and just make cool stuff that we can all then benefit from. Let's see. Vulkan, what are the advantages of Vulkan over C? Those are two completely different concepts. So C is the programming language. Vulkan is a graphics API. So, like, similar to OpenGL or DirectX, right? So yeah, they're completely different concepts. You never have true ownership of corporate code. You never have any ownership of corporate code. It's an amalgam horror of 20 different people since 1990, and you cannot just decide to really focus down on polishing a neat thing. The business constraint makes it cogs and wheels, not an invention and creativity. So all of that but also you're never given the time to actually fix things and do things properly. So you wind up having to cut corners and do hacks and gross stuff. And that adds up, right? I'll be changing that with my tutorials already in progress. Don't worry, folks. I know this is pain. I know this pain. Awesome, Spiro. I look forward to it, buddy. Speaking of which, if you guys aren't following, Spiro, you should do it. He's a Giga Chad, for sure. Feel like you can learn the same amount of stuff in college learning yourself, but it looks badly at two employers if you don't go to college, even if you understand the stuff just as well. So there is that when you're first starting, right? But like once you're further into your career, it doesn't really matter. If you have a solid portfolio of work, you'll be okay. Learned everything I did for free. It's doable. You can make it. Yep, exactly. Same here, Spiro. Like all the programming stuff, the stuff that I actually do now, I learned it all on my own. I didn't go to school for that. I don't have a degree in programming. Good college will give you a great foundation to build on top of. The majority of learning will be self-directed. That's true. But college takes you from knowing nothing to a place where you have some sensible structure to build on. If it goes correctly, and if it's a decent college, and if the instructors know what the hell they're talking about, and they don't always. Those three things are not always true for all colleges, right? So all colleges are not made equal. People don't realize college is mostly teaching yourself anyways. It's usually just presented in a way that builds on itself as you go along. That's absolutely true. The amount that was quote-unquote taught to me versus the amount that I taught myself there's a huge disparity there. For sure. About to finish up my final year of college, and looking at the debt racking up and depressing considering how bad the industry and economy is and will be when I graduate. And every single topic I learned could have been self-taught, but I did it to check off the employment boxes for degrees. I did the exact same thing. So Xerox machine, I feel that to my core. When I got out of college in the beginning of 2009, which, if you know anything about the economy's history, at least here in the U.S. and, well, really around the world, the economy took a nosedive in 2008, right? And I graduated and went into the job market right after that. Perfect timing, right? Yeah. It took me hundreds of applications before I got an entry-level job somewhere, just doing something that I absolutely hated, but paid the bills. So, yeah, I feel you. Hopefully you fare better than I did back then, but, it sounds like you're motivated, which is good. That helps a lot. So definitely good luck there. In my opinion, if you don't consider yourself self-taught, then you probably aren't taught at all, college or not. That is well spoken. I would agree with that. The worst interns, hands down, I've ever had were computer science interns. Really? Internal static void, why is that? Out of curiosity. Because that's interesting to me. Let's see. Yeah, Spiro, no problem. Good college is doing a lot of heavy lifting in that statement. Yeah, exactly. Yep. Piece of paper is super useful for getting a job, though. At least when you're fresh out of college. Yes, it is. Depends on the industry, right? Unfortunately, computer science still wants a degree for a lot of things, but once you have that sort of what they call equivalent experience, once you've been doing it for 5 or 10 years, that becomes less and less important. Computer science, I think, as a whole, generally fails people who want a programming job. I tend to agree. I think they teach you just some basic stuff, and they don't go as deep as they probably should, or as there's not like specializations, I think, right? Like, there ought to be some sort of way in computer science programs where you don't just learn the general stuff, but then you can also deep dive on something for 4 or 5 different courses, right? Whether that's web development or back end development or embedded or something like that. Like, they don't teach that stuff in college. Also, we developers need to do a better job of gatekeeping it. Gatekeeping what? You mean like keeping the vibe coders out? I agree with you there. Most of them just didn't know how to code, how to think like a computer. Yeah, and that's not something that you can really teach somebody that doesn't want to learn it. And unfortunately, you're not going to ever get around that. You're always going to have that no matter what industry you're in. It seems especially bad in this industry, but yeah. Electrical engineering interns would smoke computer science interns. I believe that because they're actually taught how a computer thinks and have to get comfortable with scripting at minimum. Yeah, I would agree with that. I think starting people off learning something like Python is just wrong. Everybody should start off learning C because it is a little bit closer to the metal. It's a lot closer to the metal, right? I won't say as far as assembler, although I think that's valuable, but yeah. Whereas the computer science students have just taken their first programming course by year 3. Whoa, wait a minute. Internal static void. You're saying computer science students have just taken their first programming course by year 3? Are you serious? I'm speechless. If that's... Holy crap. Okay. That's mind-boggling, for sure. And yes, I said mind-boggling. I didn't misspeak there. That is absolute insanity. A friend of mine went for electrical engineering and is doing a great job, and is doing great job-wise, but he's not much of a programmer and only codes a little bit. Crap, it scrolled. Hang on a second. Only codes a little bit when needed, but definitely doesn't learn in his free time. But he works on hardware, so he doesn't need to. I mean, I guess that's fair, right? I guess that's fair enough. But yeah, he probably can do it, but just doesn't enjoy it, which is why he went into electrical engineering and not software engineering. Did my master's in electrical engineering, and I agree with this. I've worked in building circuits, FPGA, microcontrollers, etc. Basically everything from and/or gates to Java. Yeah, see, that's awesome. That's what I should have done, to be honest. That I probably would have found useful. Actual engineering, right? Where you have to take the what's the name of that test you have to take? I can't think of the name of it now. GRE? Is that it? Is it the GRE? I can't remember. My university started with a C and then right into Java. And we got to choose our mastery language, which are 2 classes in either C++ or Java. And I went the C++ route. You probably went the better route, but yeah, like, why right into Java, right? Like some time should have been spent on C for sure. Python is good to learn for, if, while, what a function is, etc., but need to move on to something like C ASAP. See, I would argue you can learn all that stuff in C just as easily. I don't think the Python step is necessary, because all that stuff is super simple in C as well. I think a lot of people would have been better served by being taught programming vocationally instead of academically, more like a trade, really. I agree with that, because actual experience is the best way to learn. Most of the interns were year 2 and 3 when I asked. Year 2 students had to seek out a programming course. The year 3 guys, Java and Python weren't mandatory until year 3. That is crazy. What are they doing the first 2 years then? Like, what are they actually doing for 2 years. Help me understand. So I know how under the hood computers work. Yeah, exactly. That's the thing, right? Like, I can't necessarily go down to the hardware level, but I have an understanding of it because I took the time to read about it. What color scheme is this? This is Adwaita, I believe. Adwaita. Honestly, I prefer C as opposed to Python because I think the language is. Wait, I think that languages like Python are too object oriented for me, and I disagree with the people who think Python is easier. Yeah, I think the the problem is this. Like I said earlier in the stream, like you need to know object oriented programming to get to go into the industry. Even if you don't use it, you need to understand what it is, how it works, and why you're using it or not using it. Um, the reality of it is a lot of the jobs that are out there are going to require you to do OOP, right? But I think it's a mistake to start off learning OOP. I think you should start off using a language like C that's procedural, and then OOP stuff can come afterwards. All the theory stuff for the first 2 years, it's like discrete math, OS, that stuff. I mean, I get some of that, but 2 years of it before they even touch programming? That seems crazy to me. Capstone project in CS is the final project after 2 years. Associates, wait, I assume that's what that means. Associate of Science had a whole team of people who didn't even have a GitHub account, didn't know how to use Git, and only coded with GPT. Okay. And I had to write the entire full stack application myself. That made me never want to let AI write my code. Don't get me started on ChatGPT. Don't even get me started on that and how people use it. Yeah, it's the worst thing to happen to computer science college students. I would say the worst thing to happen to computer science, period, with how people rely on it. Just as if there wasn't enough rubbish code out there anyways. Now you've got this thing sampling all that rubbish code and putting out and suggesting more rubbish code. Like, it just, oh, okay. Yeah. I mean, sure, if you want it to explain something super simple like inverting a binary tree, then maybe it's okay. But even that code is probably going to be crap. Started college right when LLMs took off, made school feel dystopian. Yeah. And that's the thing, like, anybody with experience without those things understands how bad those things are, but the people who don't have the experience think it's the best thing since sliced bread. AI in general is just a net negative, is what it is. Yeah, I agree. There has not been. Think of all the bad stuff that's happening out there because of AI, right? And I don't want to go too far down the rabbit hole, but like, just think of all the bad stuff that happens now because of it. All the deep faking and all of the the hacking that goes on, all the misinformation, the hallucinations that it does, all the other stuff, You don't think of it. Yeah, the thing is, you don't think. You let it think for you, which it's not even thinking. It's just generating tokens. But yeah, yeah, that whole thing is just it's terrible. It's terrible for this industry. Absolutely. Thank you for the follow, by the way. You coded an AI before. So when you say you coded an AI before, did you code one like before ChatGPT or any of that stuff existed? Net negative for us, net positive for all those companies that want money. Every day some startup is created. You know what's going to happen though, Jeet, is all that stuff I predict somewhere in 2 to 5 years. all that stuff is going to come crashing down when people realize how crap it actually is under the hood. Especially for things like programming, because it doesn't understand context, and it can't understand context past a certain point. And even that point is very, very minimal. I think the hype eventually going to die out. All the funding for that stuff's going to disappear, and it's going to be... You're just going to see all these companies come crashing down. I think AI coding is bad, but the impact on the art community is quite sad. I agree with you there, too. Yep. It's funny to, like, go and generate goofy AI songs that, are funny and stuff, but, like, people are actually releasing, records generated by AI, and it's just garbage. Net negative for humanity, I agree. Yeah. Thank you for the follow, by the way. Feel so bad for the artists and designers. There's no intelligence, it's just training on data and Jeopardy giving answers. That's not intelligence. Yeah, the fact that they even call it... Like, AI is just such... It's a wrong term for it. I don't know what the right term should be, but it's just nothing but a bunch of weighted averages, basically. Anyway. Unfortunately, we are out of time for tonight. Right term is data scrapers. Yeah, that's true. Because it does scrape everything. Thank you for the follow. Appreciate that. So yeah, speaking of work things, I have to get up and go to work in the morning early. So I'm going to have to end. But I'm going to be... let me look for somebody to raid. But yeah, thank you guys for being here. I really appreciate it. Appreciate you guys hanging out. And if you haven't already, I would greatly appreciate a follow. I know I've gotten a bunch of them tonight, and I really appreciate you guys. But yeah, if you haven't already, feel free to toss me a follow either on the YouTube side or the Twitch side. And then next time we are online, hopefully we get a little bit further with this stuff. Let me just find somebody to raid. I'm going to have to do a raid and run tonight. Let me see who is... Let me see who's online. Kind of hoping to find something kind of similar to what we're doing here, if it is available. Might not be, though. I don't see... All right, I think I know who we're going to go with. We are going to go with... We're going to go with Z.A. Shaw. He's doing C++ game dev. He's working on a retro future raycaster. So let's see what he's up to. It looks like... I'm not sure what... Looks like he's doing shader stuff potentially right now. So... yeah, we'll take a look and see what he's up to. But yeah, thank you guys so much for joining me tonight. I really appreciate it. And yeah, that's going to do it. I will see you guys on the next stream. See ya.